In the next 15 minutes, we are going to break down every single AI node available in n8n, what they are, how they work, when to use which one, and most importantly, why. I promise you will come across tools and techniques you have probably never seen before. So stay sharp, this video is going to level up your AI workflow game big time. And as a bonus, at the end of the video, I'll give you a ready to use n8n template that you can plug in directly for easy reference. Let's dive in. The only prerequisite for this video is that you should know what n8n is and how you can create workflows on this platform. Once you land on the dashboard, you can click on the plus button. Let's take a look at all the available AI nodes first. So let's pull the trigger manually node over here. And now if we go back, we will see this AI tab over here. If we click on this, we will see all the AI related nodes. Now there are two categories of these nodes. The first category is the primary AI nodes, which comprises of all of these nodes over here. AI agent, OpenAI, Basic LLM Chain, Information Extractor, Question and Answer Chain, Sentiment Analysis, Summarization Chain, and Text Classifier. Now these are the primary nodes that you will use to interact with LLMs and to create agents. And then we have the second category of nodes, which is secondary nodes, which are grouped together in the other AI nodes tab. If we click on this tab, we will see all of these nodes. Now these are the different types of supporting nodes that are required by the primary nodes to function properly. And this category includes document loaders, large language models, memory, output parsers, retrievers, text splitters, tools, embeddings, vector stores, and some miscellaneous nodes. Now we will be covering all of these nodes, and at the first sight this may look overwhelming, but once you understand how all of these nodes tie together in the bigger picture, everything will seem easy. Now to keep the things really easy to understand, here's how we are going to cover all of these nodes. We will not cover each of these secondary nodes individually because that won't make sense and it will become difficult to understand. Instead, we will set up these primary nodes, and then these primary nodes will require their corresponding secondary nodes. So we will cover the supporting nodes along with the primary nodes so that everything makes sense. So first, we will cover the AI agent node, and along with the AI agent node, we will cover the large language models, memory, tools, and output parsers, which you can find in other AI nodes. Next, we will cover OpenAI, Basic LLM Chain node, Information Extractor, then Sentiment Analysis node. After that, we will cover the Summarization Chain node. And along with this, we will cover the document loaders, which is this one over here. Next, we will cover the text classifier node. After that, we will see how to create RAG. And finally, we will take a look at the question and answer chain, which will use retrievers. And while doing that, we will cover this tab over here. And at the end, we will cover the miscellaneous nodes, where we have the chat memory manager, Langchain node, and the OpenAI. And that will mark the completion of this video. Now let's start with the first primary node, AI agent. If you want to understand how to build a perfect AI agent with the best configurations and settings, I highly recommend watching this video. AI agent primarily requires these three things: chat model, memory, and tool. If we click on chat model, we will see a list of all the chat models available in n8n that we can attach to this AI agent. Choosing the right model depends on what you want your AI agent to act like. Anthropic or Claude models are excellent for long documents, and they provide a safer, more aligned tone in their responses. Azure OpenAI is nothing but OpenAI hosted on Microsoft Azure. It offers the same models as OpenAI, but with the added benefit of enterprise-grade security and compliance. And it's a great choice if you're working in a corporate environment. AWS Bedrock gives you access to various foundation models hosted on AWS. So if you have restrictions where your data can't leave your AWS environment or infrastructure, then you may want to consider this one. DeepSeek is strong in coding and reasoning use cases. Google Gemini has multi-model models which excel in text, vision, and voice. So if you have those kind of requirements, you may want to consider this one. Grok is known for its ultra-fast, near real-time responses, and it's great when latency matters. Mistral and Ollama are open source models that can be self-hosted. They give you the full control over your data and infrastructure. OpenRouter is a very handy platform. If you don't want to create separate accounts for different model providers like OpenAI, Anthropic, etc., with one OpenRouter account and a single API key, you can access and even compare multiple models in one place. This makes experimenting and benchmarking really easy. Now let's talk about OpenAI models specifically. OpenAI has reasoning models like O1, O3, and they're really powerful and they're perfect for brainstorming and complex problem solving. However, they're also most expensive. Then there are models like GPT-4o, 4.1 that are great at general purpose use like summarization, question answering, and content generation. And then there are cost optimized models like GPT-4 or Mini and GPT 3.5. These are lighter and cheaper, and they're good for straightforward tasks where performance can be traded off for cost. Now, to summarize, if you're tied to specific cloud providers like Azure or AWS, then you can consider respective models. If accuracy and reasoning are priorities, then you can explore GPT-4 or Anthropic's Claude model. If privacy is critical, then consider self-hosting open source models like Mistral or Ollama. But in most of the cases, your best bets will be OpenAI, Anthropic, and Google Gemini. They offer a solid balance of power, safety, and usability. Next, we need to attach memory to this AI agent. By default, AI agent doesn't remember anything. But if you want this agent to consider the previous conversation history to work on the current new query, then you need to provide a memory to this agent. Agent will automatically store the new message received and the response it generates in that memory, so that when the next message arrives, it will refer back and pull those previous conversation messages to make sense out of the new message. We have these options for the memory. The simple memory is supposed to be used only for demonstration and testing. It shouldn't be deployed for production because the chat history is not stored on your hard disk. It stays in the memory and will be easily lost. And if you have a huge traffic, it will impact the n8n's performance. Depending on which service you are using, you can pick any of the other memories and attach it to the agent. Next, we have tools. As you can see, there are a large number of predefined tools that you can attach to the AI agent. If your service or your action is not listed here, you can create your custom workflow, or you can write your own code, or you can make a custom HTTP call to your service and add it as a tool to the agent. You can also attach MCP client to the agent and attach all the tools to the corresponding MCP server. If you are not sure what MCP is or how it works, I highly recommend watching this video. Next, if we open the AI agent, we will see this option over here, require specific output format. If we enable it and exit from here, we'll start seeing a new option called output parser. Now, since this AI agent is not the complete workflow, but it's just a part of it, we want this AI agent to output the responses in a certain format so that we can use that output and take appropriate actions on various fields returned in the output. And output parser just enables us to do that. If we click here, we will see three different options for output parser. We have structured output parser, then item list output parser, and auto-fixing output parser. First, let's understand structured output parser. In this parser, we need to give a JSON, and then AI agent will analyze this JSON and will try to match the final output according to this JSON. So let's take an example where we want this AI agent to act as a social media post creator. So let's add a system prompt to this AI agent, and it looks like this. We have given the role, primary goal, domain knowledge, and output. In the output, we are saying generate an Instagram post as per the user's query. Now let's go to the structured output parser and give this JSON. Now this JSON contains three fields: title, caption, and tags. So this is what we are looking for from the agent. Now let's open the chat and give a query, create a post on top 5 AI tools, and let's run it. The agent is running and it has used the structured output parser and it has given this output. As you can see, it has given the title, caption, and the tags. It's the format that we wanted. Next, we have item list output parser. So we may have a use case where we want this agent to output an array of objects. For example, if we give it a document and we ask it to fetch all the questions from that document. For that purpose, we have the node item list output parser. Here we can define the separator by which the posts should be separated by the AI agent while creating it. And finally, we have the third one, which is auto-fixing output parser. It is nothing but it's a wrapper on top of these two, because agent may hallucinate and it may not give the proper output in the first go. For that purpose, we attach auto-fixing output parser. And to this auto-fixing output parser, we can attach our structured output or item list output parser. And in the model, we can select any model we desire. Now, the way it works is the agent will first try to come up with the correct format that we have defined in the structured output parser. However, this auto-fixing output parser will check if the received final response from the agent matches the JSON that we provided over here. If it doesn't, then it makes one more call to the OpenAI chat model to get that response fixed. So this ensures that the output we receive from the AI agent is always in the format that we need. I've seen people using AI agent for almost all the AI requirements, and that's a really big mistake because it not only reduces the performance of the AI agent, it increases the hallucination and the cost. Though there is nothing that this AI agent can't do that these other primary nodes can, but still using AI agent for every use case makes it ineffective and difficult to implement. And we will cover that in just a moment. Let's move on to the next node, which is OpenAI. OpenAI is nothing but it's a vanilla HTTP request to OpenAI. You can create an assistant, you can message a model. It will be a simple message. No memory will be involved over there. You can generate an audio, an image, you can transcribe a recording, and so on. Next, let's talk about Basic LLM Chain. This is a very basic node that receives a query and it makes a single request to the model that we select over here, and then it responds back with a response. Now there is no memory involved or there is no tool that you can add to this node. So it's a plain call to the LLM. However, it's different from this OpenAI node that we just talked about. If you open this node, at the top, we will see the prompt. This is the user's message that this node needs to respond back to. Then as we discussed, we can select specific output format for this node. And in the chat messages, we need to add the prompts. Now there are 3 different types of chat messages that we can use in the basic LLM chain. The first one is system. This is the system message. It doesn't change in a conversation. So here you tell what it needs to do. For example, you are a helpful assistant for XYZ dental clinic. So that message comes over here. Next, you can also add a user message. So this can contain text, image, or a URL for the image. And we can also add the chat message of type AI. It is used for few short examples that shows the model how to respond. So for example, here you can add something like, shortly, thanks for reaching out, your booking is confirmed. And then we have a really powerful feature in this node, which is batch processing. Now in the batch processing field, we can select the batch size and delay between batches. So let's say before the basic LLM chain, we add a Google Sheets node that will fetch multiple rows, let's say 100 rows from the sheet. And those can be like blog ideas. And now let's say we want to make a call to the OpenAI model to create the outline for those blog topics. Now one way is to make 100 separate requests for all of those blog titles. But another way is to optimize the cost. And the way we do that is by batching. So in the basic LLM chain, we can add a batch size of, let's say, 20. So what it will do is it will make the request in batches of 20 rows. So if the total number of fetched rows were 100, the total number of requests to be made are only 5. And since OpenAI charges both on the number of requests and the number of tokens, this reduces the overall cost. Of course, you need to make sure that you're not hitting the throttling limits from the OpenAI while setting these sizes. You can also add delays between the batches so that you don't hit those limits. And this is how it's different from the simple OpenAI node. It's more powerful than that. At the same time, you don't want to use the AI agent node if you don't need the tools and the memory. It's because AI agent node uses React pattern. So it's programmed to run through a couple of loops to get all the available tools and then identify the next set of actions it needs to perform. And that leads to some latency. However, if your use case is simple, where you just want to make a call to LLM, basic LLM chain node is what you would want to use. Next, let's talk about information extractor node. Let's consider a case where you received a message from the user or you have some text and you want to extract some details out of that text. For example, address or phone number or email ID or anything else. Now, one way to do that is to use AI agent. And the way we do that is by adding a prompt in this AI agent where we ask it to parse the content that we are providing it and extract the specific information and then output it in the final response. Now, the problem is that in the AI agent, we need to enable this specific output format and then we need to add the output parser. Then maybe add auto-fixing output parser and then structured output parser. In the structured output parser, we need to define a JSON ourselves. And if the JSON looks a little complex, we have to take care of everything. It means that it opens a loop for hallucination and mistakes. Now, all of this can be avoided by using information extractor. In this scenario, we don't need the memory and the tools. So AI agent is not required. The way we use information extractor is we need to add a model which will act as the brain for this node. And in the text, we can give the user prompt or the text that we want the information to be extracted from. After that, we can define the attributes that we want to extract. So it's like instead of defining the JSON in the structured output parser, we are defining all the attributes that we want. And internally, this node will take care of converting all of these attributes into a proper JSON. And then this node will retry until the final response aligns with all of these attributes. So it gives us the surety of getting all the required attributes in the defined format. So here we can give an attribute, we can define the type like boolean, date, number or string, and we can give a description over here. It makes things easy and more performant. Next is sentiment analysis node. This node is used to identify the intent or the sentiment of the text. Let's say if we received a message from the user, we can put that text over here to analyze. And here we have multiple options. First, we can define the sentiment categories. By default, we have positive, neutral, negative. We can in fact change these to happy, sad, or angry, or anything else. Next is system prompt template. So by default, this is the template which is used internally by this node, but we can change it if required. Let's say if we want the sentiment in a different language. If no change is required, you can remove these. Next is include detailed results. So what this does is it attaches a score to all the sentiments that this node identifies for the given text. Now let's see this in action. So I've set the sentiment categories as happy, satisfied, and unsatisfied. And let's give a message over here. I waited for 2 weeks for my order, but the support agent was kind and helpful. I'll recommend the product to others. Let's say this is the message that needs to be analyzed. And in this node, let's drag and drop the chat input. And now if we execute it, we got the satisfied branch. Now in the options, if we enable include detailed results and execute this again, this is the scores. Now, depending on these scores, we can have logic in the workflow later on. If the confidence is, let's say, greater than 0.7, then we'll take a certain action. And we should always enable auto-fixing. It's because internally, if we look at the system prompt is requesting the LLM to return a JSON in a given format. And if we enable autofixing, then if the return format is not correct, then it will make an additional request to the LLM to get it fixed. So that will ensure that we'll always get one of the categories defined in the sentiment categories field. And finally, we have this powerful feature of batch processing. Let's say we have predefined data in Google Sheet or Airtable, and we want to analyze the sentiment of all of that data. So we can have a Google Sheet node or Airtable node just before sentiment analysis. We can fetch all the rows to be examined, and then we can add a batch over here with a batch size of, let's say, 5. What this will do is it will make one request for 5 rows each, and it will lead to a reduced cost because the node will make lesser number of requests to OpenAI. You can also add delay between each batch so that you don't hit the limit in OpenAI. As you can see, we can achieve all of this with the AI agent node, but it's just additional work which is required to set it up. Here, a lot of things are already handled for us. We just need to define the categories. System prompt is already there. So there are lesser chances of going wrong because this prompt is proven to work. And we also don't need to set up the structured format for the responses. And we get this powerful feature of batch processing. Next on the list is summarization chain. Now this node is used to summarize a given content. It can be a small text or it can be documents. At the top, we have data to summarize. And we need to choose what kind of data this node will receive. It can be a JSON or it can be a binary file, or we can use document loader. Next, we have chunking strategy, and we have two options. One is simple. In a simple, we define the number of characters per chunk. By default, it has 1000, and then there is a chunk overlap of 200. What it effectively means is if we have a content like this, and let's say if we limit the number of characters to 50, and let's say the number of 50 characters ends here, then it will make a split over here. As you can see, this is not very efficient because it may cut words, sentences, and at the end, the chunks may not make a lot of sense. For that purpose, we have an overlap. So when we define the overlap of 100, it will add the previous 100 characters from the next split, which may look something like this. So this part is coming from the previous chunk. This is still not very good because you may have incomplete words or sentences in this chunking strategy. So you can go for advanced splitting strategies. And when we select the advanced and go back out of this node, we'll start seeing this text splitter option. If we click on this, we will see these 3 splitting techniques that we can choose from. So the first one is character text splitter. And this is the basic text splitter that we just talked about. So it will split after a fixed number of characters. A better version of this is recursive character text splitter. And this is recommended for most use cases. So what it does is it tries to split first by paragraph, then by sentence, and then by the word until the chunk fits the length that we have defined for a chunk. So it tries not to split in the middle of a word or a sentence if possible. And token splitter is where we define the number of tokens after which we make a split. But out of these 3, the recursive character text splitter is the best one. Once we select this, we need to give a chunk size, and in the chunk overlap, we can give the number of characters that we want to overlap across chunks. So let's say 100. Next thing is we need to select the model for the summarization chain. Let's select OpenAI. And if we go back in the option, we have summarization method and prompt. So there are 3 different types of summarization methods. The first one is map reduce. What it does is, let's say we have 20 documents. So it will summarize all the 20 documents individually. Let's say we have 20 chunks for a given document or multiple documents. What this will do is it will summarize each of those 20 chunks individually, and then it will summarize all those summaries to get a final summary. In the refine mode, it will first create a summary of the first chunk, and then it will keep summarizing the rest of the chunks, and at the same time keep updating the first summary that it created. And the third is stuff. So this is where we pass all the chunks at once to get a final summary. As you can see, we can't use stuff mode if we have a large number of documents or chunks because it will go out of the context window of the prompt. So map reduce is the best one out of these 3. We have additional options of batch processing. In the batch processing, we can define a batch size and delay between batches as we discussed earlier. Now in the data to summarize option, JSON is quite straightforward. We will receive the JSON from the previous node. Same goes for the binary. Let's select binary and see it in action. So I've added this Google Drive node, which is downloading this file from my Google Drive account, and let's summarize it now. And we have got this summary of the document. If we look at the recursive character text splitter, these are the chunks that got created out of it. If we select document loader in the data to summarize field and exit from here, we will start seeing one more option called document. And if we select this option, we can't select the text splitter separately. So we need to remove this. And then when we click on the document, we have two options: the default data loader and GitHub document loader. Default data loader will load the data from the previous step in the workflow. So if we select this, this is where we need to set the text splitter. Let's select recursive character. And now if we run it, we should get the same output. And there we have it. Similarly, instead of default document loader, we have an option to select GitHub document loader and load the document from the GitHub. We need to connect the credentials. We need to give the repository link, the branch name, and again set the text splitter to recursive character split, and then we can use it. Next on the list is text classifier. Now this is somewhat similar to the sentiment analysis node, where we need to give a text that we want to classify. We can define various categories and we can give a description on when to select this category. And in the options, we have somewhat similar options. We have system prompt template, enable autofixing that we should always enable. Then we have batch processing, and then we have an option on what to select when there is no clear match. So we have options to discard them or output an extra other branch. And there is an option to allow multiple classes to be true. So if the given text is getting classified into multiple categories, it will be allowed if this option is selected. Now, before moving forward, we need to understand the concept of RAG and along with it, embeddings. So imagine you're chatting with an AI assistant and you ask it a very specific question, like, what's the refund policy of XYZ company? A regular AI model might try to answer based on what it was trained on, but it might not know the latest information or give you a confident answer. And that's where RAG comes in. RAG stands for Retrieval Augmented Generation. It means the AI doesn't just rely on what it already knows. It first retrieves the most relevant information, like pulling documents, facts, or web pages, then generates a smart answer based on that information. So instead of guessing, the AI looks things up from a trusted source and then gives you a well-informed, natural-sounding reply. It's like giving your AI a brain and a library card, so it always answers with up-to-date and factual information. This is a very small workflow where I'm downloading a file from the Google Drive, and then I've added the Superbase vector store node and then added default data loader, which is using the binary data it receives from the previous node, and then it splits it into multiple chunks of size 1000 and with overlap of 100. And finally, this Superbase vector store will create embeddings and will store them in the Superbase. Let's run the nodes and see what happens. As you can see, this Superbase vector node produced 8 items. So these are the 8 embeddings that got created and saved in the Superbase. And now, since we have data in our vector store that was produced from the document, if later on we ask some question to some AI agent or some other node, and if we give that node access to this same Superbase vector store, it will be able to answer the questions from this information. And now let's talk about the question and answer chain node. As you can see, the question and answer chain doesn't have the memory or the tools option. So if your use case doesn't require tools or memory, question and answer chain is what you should be looking for, specifically when you're looking for RAG, because this node will be faster and cheaper than the AI agent node. We have these two options: system prompt template and batch processing. By default, there is a system prompt in this node. We can modify this, but we don't need to. And next option is for batch processing, where you can batch multiple requests as we discussed earlier. Now, since it's a question and answer chain, this node will make requests to OpenAI model along with some additional information that it has. And it will get the information from the retriever. So in the retriever, we have these 4 options. Let's understand all of these 4 options one by one. Contextual compression retriever and multi-query retriever are the wrapper nodes, and vector store retriever and workflow retriever are the leaf nodes. That is, when we start adding these retrievers in this node, if we add contextual compression retriever, we still need to add one more retriever, which is the leaf retriever node. So we need to add either vector store retriever or the workflow retriever to end this flow. Similarly, if we add multi-query retriever, we need to add the leaf retriever node, which can be either of vector store retriever or workflow retriever. For example, let's add workflow retriever. So this is how it ends. The wrapper retriever just adds some logic and then delegates it to the base retriever. And that's why if we add multi-query retriever, it immediately shows one more retriever option. So now the question is, which node should we use? So it's really simple. So the most basic thing we can do is we can use the vector store retriever. Here we can limit the number of embeddings that we will receive from the vector store search. And then we need to select the vector store. So in the RAG workflow that we just discussed, we used Superbase to store the embeddings. So we can select the same Superbase vector store over here. And then in the embedding, we need to select the same model that we used to create the embedding, which was OpenAI embeddings model. Now this is the basic setup and this will work fine. However, there could be some limitations. One of the limitations is that the query from the user can be quite vague and they may not use the same words which are present in your documents and vector store, because words can carry multiple meanings. So in that case, if you want to improve your hit rate, what you can do is you can rewrite the user's query into, let's say, 5 different forms. And then you search for all of those 5 queries in your vector store. Then you fetch all of those documents and then you prepare the final response. This increases the chance of matching the documents in your vector store. Now, to be able to do that, we need to add the retriever, which is multi-query retriever. So this node is nothing but it's just a wrapper which will make a call to this LLM model and have the initial user's query rewrite into multiple forms. You can define that count over here, and then it will search all of those queries in the vector store using the vector store retriever. So this dramatically improves the performance of your RAG. Now, instead of vector store, you can also have another n8n workflow that will search in the embeddings, or it may fire some SQL queries into your database to get the relevant results and then return them back to this multi-query retriever. Now, to be able to do that, you can select workflow retriever. Here you can select that workflow. So this workflow will receive all of those 3 queries, and then workflow can search accordingly and return back the results. Now, it may happen that the number of results returned are really huge. It means that they'll cost you a lot of tokens. Now, one way to optimize the cost over here is using another retriever wrapper, which is contextual compression retriever. If we use this node, we can define a cheaper model from OpenAI. Let's say we select GPT-4o mini, and then we can attach the same retriever that we were using earlier. Let's say it receives large number of matching documents. So the task of this node is to send all of those matching documents to this LLM model and have them compressed. It removes irrelevant content and then finally returns back the relevant content back to the question and answer chain. And then question and answer chain will make the final call to the more expensive OpenAI model to prepare the final response. So this is how you decide which node to use for the retriever. Finally, we have these 3 miscellaneous nodes: OpenAI, Chat Memory Manager, and Langchain node. Chat Memory Manager is like a middleman that moves messages in and out of the memory store so that we don't have to deal with specific logic to insert and delete messages from the database. So in the AI agent, we provide this memory, and AI agent takes care of saving the user messages and the response that it returns into the memory. At certain instances, you may also want to fetch the existing conversation history to take certain action. Let's say you want to evaluate a particular conversation history and you want to use summarization chain. In such cases, you want to get all the existing conversation messages. To do that, you can use Chat Memory Manager, and in the memory, you can select the same memory that you used to save the messages. And in the Chat Memory Manager node, you can select the operation mode as get many messages, and it will fetch all the messages. You can use this node to insert the new messages or in fact delete messages. Another miscellaneous node is Langchain code. It's a sandbox where you can write raw JavaScript or Python Langchain code and execute it right in n8n workflow. At the top, you can supply data or you can execute a piece of code. You can add inputs such as chain, document, embeddings, and so on, and you can define the outputs that you are expecting from this node. To be able to effectively use it, it requires some understanding of Langchain constructs. So I'll create another video to cover this Langchain code node in detail later on. So far, we have covered all of these primary AI nodes, and we have covered all of these other AI nodes like document loaders, language models, memory, output parsers, retrievers, text splitters, tools, embeddings, vector stores, and miscellaneous nodes. And if you're still watching the video, congratulations, you now have much deeper understanding about all the AI nodes in n8n than most of the folks out there. If you want to learn how to build highly effective, reliable, and high-performant AI solutions that work in the real world, do check out my upcoming pro community. You can find the link in the description. And you can download this template from the free Skool community. You can find the link in the description. Just create a new workflow, import it, and then you can use it for reference later on. If you have any questions, leave them in the comments. And if you found the video useful, do like the video and subscribe to the channel for more content like this. Thanks for watching and see you in the next one.